So this is a presentation on LabVIEW interfaces. Quick overview of the agenda or plan for today. I'm going to quickly talk about myself, my company, who we are, what we do, then a little brief overview on object-oriented programming in general, interfaces in general, kind of separate from the specifics of LabVIEW implementation of interfaces. And then the bulk of what I'm going to talk about are some concrete use cases, how I actually use interfaces in my code, how I found them useful, what types of things I've done with them, and how I think other people might be able to implement them themselves, and then some closing thoughts. And I'm also going to kind of throw a few random thoughts about AI in here and there. Got a couple comments that we'll get to there. So first, I also want to just kind of throw a quick shout out to GDevCon. This is a presentation that I gave at GDevCon last summer. It's a really awesome convention. If you haven't been to it or conference, I very highly recommend it. I was talking to someone else about it last night versus kind of coming to NI Connect, and the person said basically I tend to get more technical, useful stuff out of going to conferences like GDevCon, which has been my experience. One of the things I really like about it, at least at the moment, their format is one big room where all the presentations are, so you don't have the problem of there's 3 presentations I want to see, but they're all at the same time, right? I think most of us have had that where the 2 things you want to see most when you come to NI Connect are at the same time. That's not an issue there because all the presentations are all at the same room. And it's just it's a really good group of people, lots of very smart, very technical content. So yeah, very, very highly recommend checking it out. If you haven't been, if you can't go this year, try and make it the next year or another year. And even if you aren't able to go to GDevCon, I think just wanted to plug for getting involved in your local LabVIEW community. It's really helped me grow as a programmer, and it's great to just kind of grow your network of people through events like this. So big plug for that. And I appreciate the support of the folks at GDevCon, and that was kind of what roped me into presenting here. So just a big shout out to them. So my name is Paul Ross. I've been programming LabVIEW for about 12 years, something like that. Personally, outside of the professional life, I really enjoy meditation. It's a big part of my life, who I am. I spend a lot of time just kind of sitting and looking at my thoughts, looking at my breath, feeling sensations in my body, all that good stuff. Brazilian Jiu-Jitsu, I love getting sweaty and rolling around on the ground with other men, usually. It's a good time. And then just kind of being out in nature, riding my bike, running, things like that. And I'm a managing partner at Compose Systems. Compose Systems is a small software consulting company based in Massachusetts. We primarily use LabVIEW. We do have some projects where we're not exclusively using LabVIEW, but primarily LabVIEW software consulting. Pretty much everything we do is object and actor-oriented. I'm not a person who thinks that you have to use object-oriented code to write good code, but I personally feel that for me, it helps me write better code. And the folks that I work with all kind of tend to agree. So pretty much everything we do is object-oriented, actor-oriented. We're really kind of emphasize trying to write really clean, solid code. Most of our customers are either in the semiconductor manufacturing control system world or manufacturing line automation. We do have a few other customers that kind of run the smorgasbord of things that NI connects into, biotech, things like that. But these are kind of our main areas that we focus on. So if you're in this room, I'm assuming that most people in this room are at least somewhat familiar with object-oriented programming. I often will hear people who don't use object-oriented kind of talking about it in a way that suggests that it's more complicated or makes code more difficult to read or understand. Everyone's brains work differently. Me personally, I find that if you're using object-oriented code correctly, which that's a difficult game to win, but if you are doing things right, it should make your code easier to understand, easier to read, easier to reason about. It helps me to think about computer programs as a bunch of behavioral entities, and that really maps in my brain to the way object-oriented programming works. So that's my plug for OOP. Why I use it, I think it makes programming easier. I think it makes understanding code easier. If I pick up someone else's code and it's object-oriented, that's at least somewhat well-designed, I think it's easier for me to understand than non-OOP code. So classes and abstract classes. Interfaces were a new feature added to LabVIEW, but they've existed in other programming languages as a distinct entity from abstract classes for a long time. Classes and abstract classes kind of define a common relationship between classes. You can have concrete or abstract methods. Most languages, it's single inheritance. That's the case in LabVIEW. And there's a hierarchical relationship between classes. Whereas interfaces define a behavioral contract between classes. Depending on the language, you can have abstract or default methods. Some languages, interfaces are purely abstract. You can't have any implementation. Some languages, you can't have a default implementation. There's multiple inheritance, and the relationship is really a behavioral one. So the core difference to think about when looking at a class and abstraction versus an inheritance, or versus an interface, is that an interface defines a can-do relationship and a class defines an is-a relationship. So this is the example of an interface is I can squeak. So a mouse can squeak, an old door can squeak, a rubber chicken can squeak, although none of those things are the same thing. So this is a little image that last year when I asked ChatGPT to, when I gave this presentation, I asked ChatGPT to generate an image for me that was an animal hierarchy for a presentation on object-oriented. This is what it came up with. Cat is a mouse is a dog. And at the time, I put a note, AI isn't taking your job anytime soon. The 2026 update, maybe it is. So just I said I was going to babble a little bit about AI. Just as a curiosity, the other night I asked Claude to generate a presentation on LabVIEW interfaces for me, just to see what it would do. It generated a full 30-slide deck presentation. As AI does, it kind of generated 1 or 2 slides that were complete nonsense and said things that were incorrect. But 28, 29 of the slides were actually really good, useful information, gave me some interesting ideas. Then I took this presentation and I uploaded it and said, well, what do you think about this one? And it said, oh, that's actually much better because AI is trained to make you feel good about yourself. So I said, well, okay, well, can you clean it up, add a little bit of formatting, featuring, stuff like that? And it did, and it made this really nice presentation and taking my content and reformatting it. And I had actually spent a little time last night going through it and trying to get rid of the AI-ness of it. And I hit a point where it was just like, I can't do this. I can't get up and present this thing that an AI generated and pretend like I did this. There's something about it. It's very good at creating this, like, almost to me, like it feels like a cheap, almost like a McDonald's sense where it's appealing instantly, but the more you look at it, something just feels off. And I've got a couple slides in here that are AI generated, and I'll wonder what folks think about. Is it obvious that this was AI, and what do you think about it? It feels kind of nice looking, but there's something lacking in it. I don't know. I know there's been a big focus on AI this year at this conference as a whole, and maybe we'll save this for the end. I am curious to hear more thoughts from people about how everyone is using AI, how everyone thinks about AI. I see a lot of people have very strong thoughts about it in different directions. Some folks love it, some folks hate it. One of the things I don't see a lot of people talking about, not necessarily from a doomerism perspective, but just being openly honest, which is that I'm afraid of it. I really am concerned about the effect that it's going to have on society, on the world, and humans. And I think if you're not at least a little bit afraid of AI, you probably haven't really used it to its full capability. It's astounding how powerful it is. And I can give some concrete examples of some things I've done with AI that just blown me away. But yeah, that's one little comment on that, and we'll come back to that a little bit more later. So, okay. Off from my aside on AI, LabVIEW interfaces. So they were introduced in LabVIEW 2020. Can't believe that was 6 years ago. But it's been in LabVIEW for a little while now, so you've had some time to play with it. But if you haven't, maybe I'm going to convince you to do so. So they allow multiple inheritance. By default, when you create a dynamic dispatch method with an interface, there must override. That is something that you can change. We'll talk about that a little bit later. The file type is a .lv class file type, just like a class, and there's no private data. So when you create an interface in a project, this is what you see versus a class. So the I am an interface is a square with the lines removed, and a class is the filled in square. And you don't have the private data control that you would have with the class because there's no data in an interface. So now getting into some of the use cases of interfaces. I'm just going to go through a few of these. So one is decoupling actors to improve messaging between them. Another use case that I found really useful is refactoring some legacy code, kind of creating some better interfaces between different modules to reduce coupling, then providing some default access to a shared resource and asynchronous callback APIs. Hey, look, it's an AI-generated slide. Okay, so first use case is actor framework message routing. If you're not familiar with the actor framework, it's essentially a message handling framework. If you use queued message handlers, that's the general gist, is that an actor is a asynchronously running in its own parallel thread message handler. Again, going back to what I said, that object-oriented programming tends to help me think about code, it makes sense and kind of maps to my brain of having these behavioral entities that are running independently for the types of software that I work on, where you have a bunch of instruments that are running independently, right? All these pieces of hardware are doing their own thing independently. It makes sense to have these behavioral modules in your code running independently. That kind of maps in my brain and makes it easier for me to think about how my code works and how it maps to the actual physical system that I'm interacting with. So you have these independent message handlers, and you have to usually communicate between them. So a very simple application, you've got three actors. You have a root actor, launches a actor that does some sort of data acquisition. Maybe you're talking to an instrument, maybe you're querying something from a database, whatever. It gets some data, and then you have a display that you want to display that data to the user, right? Pretty simple. The root actor launches the get data actor, and it launches the display actor. So then the question is, well, how do we get the data from here to there? So you may think the easiest way to do it would be to take your display data and give it to your display data queue and give it to your data acquisition actor. But the problem with that is, first of all, what happens when you have multiple displays? What happens when your data acquisition actor isn't getting it from a database, it's getting it from an instrument, and now you want that data to also go to a database. Your data acquisition actor is very quickly going to be filled with a bunch of junk, sending data to all these modules and coupled to all these modules. So you don't want to send it directly to this actor. The recommended approach is to send it up the chain. You send the data up to the actor that launched you, and then that actor, who knows a little bit more about the system because it launched the other actors, will then pass it to the appropriate consumers. So what does this look like? If your root actor launched these two actors, your data actor acquires some data, sends a message to the root actor. The root actor then sends a message down to the display actor. And prior to interfaces, the way to do this was with abstract type messages, because the problem here is that your data acquisition actor is coupled to your root actor by sending it a message, right? It needs to know something about that root actor to send a message to it. If you're using a queued message handler, this data acquisition actor needs to know the string name, right, to send to the case structure of the root actor to handle it properly. So there's a coupling between them. In the actor framework, that coupling is object-based rather than string-based. But it's the same idea. You've got some coupling here. Similarly, the root actor's got some coupling between the display actor. So the way to handle this prior to interfaces was to use an abstract type messages. And you could, again, if you're not familiar with the actor framework, the way you could think of this would be to inject a string, right? So if these were queued message handlers with a string and a variant queue type, your root actor, when it launches the data actor, could insert a string into the class data of the get data actor and say, this is the string I want you to send to me when you've acquired this data. You acquired this data and send me a message that says, I acquired data named whatever. You inject this string into this and it sends it up. And so the root actor knows how to handle that because the appropriate definition was injected. Same idea with objects. You inject the concrete type of message into your data acquisition actor, and it sends it to your root actor. And you've removed the concrete coupling from your data acquisition actor on your root actor. So what does this look like? Here's some concrete code. You have an injected data update message. That data update message has a method where you can pack some data into it, and then you send it, right? All that's happening here is we're enqueuing a message, and the message type was injected into this data acquisition model before it was launched. So what's the problem with this? This works. It's not really clear what's happening here to me. It's not intuitive, especially when you get into code with some complexity. This data acquisition model, if it has a bunch of messages that it's passing up to the caller, you're kind of bloating it with injected messages. Again, to me, this isn't intuitive. And I said at the beginning of this presentation that one of the things I like about object-oriented code is that if it's done well, it is intuitive. You see what's happening and it makes sense. So this isn't really functionally defined, and creating and maintaining these messages is kind of cumbersome. Okay, so this is actually one of these AI slides. I'm curious what people think about this. So I had AI say, fix this. And this obviously looks a little bit neater, but there's something about it to me that I don't know. I don't know what people think. But same thing, AI made this one. Anyways, so interfaces to the rescue, right? So we can define an interface for catching the data. The root actor and the display actor implement that interface, and the data acquisition actor knows only about the interface. I catch data. Doesn't need to know anything about the root actor, doesn't need to know anything about the display actor. It just knows that there's a launcher that can catch some data. So we define the interface, I catch data, has one method, catch data, and has a message, send catch data. So this is now what this implementation looks like. To me, this is much more intuitive than that abstract messaging where you have some random message, you don't know what it is. This is sending a message, and if you look at the name of that method, it's send catch data. So you're sending a message to the caller that's catch data. Then my root actor, in its method where it catches the data, all it's doing is taking the display actor queue and forwarding that message onto the display actor. The display actor then displays that on the UI. Does everyone know what that little method is? Some mixed nods and yeses and nos. That's a set control values by index. It's a native LabVIEW primitive function that if you don't have direct access to the terminal, so if you're updating a UI element by reference, this works, I think, multiple orders of magnitude faster than using a property node. It's in the application. Someone shout it out if you know it, what function it is. But if you just use quick drop set control values by index, so there's a property on a control. When you create a reference, you can get the control index, and then you need a reference to the owning VI. This is a little node that's significantly more performance improved than using the value property node. I think it's a little bit slower than local variables though. Anyways, so that's what the display actors iCatch data looks like. The problem with this is what happens in a real system, right? I've defined this really trivial, simple, stupid system where you've got one piece of data being passed to one module from this data acquisition actor to a UI. Real simple systems are far more complicated than that, right? We've got if you have a real system, you probably have multiple pieces of hardware. Those multiple pieces of hardware probably all acquire multiple types of data, multiple status updates, things like that. So very quickly, your application can be full of stuff like this, where you've got all sorts of message routing, right? Your actor, your root actor, and all the other actors. And that's the other thing is that, I've defined this very simple 3-actor system. Most of my projects, I have, at least 50 actors. And if half their code is just message routing, it's kind of difficult to maintain. It doesn't really scale well. So what's another implementation or a way we can kind of get around this? One way I've found to do this is to use a default implementation. So by default, as I mentioned earlier, when you create a dynamic dispatch method, the default setting is that the descendants must override, but that's just a checkbox in the item settings of the interface. So if you're familiar with the class properties dialog box for classes, there's a similar one for interfaces, and it's got kind of all the same settings. There's that checkbox, descendants must override. You can get rid of that, and then now you can have a default implementation in your interface. All right, so what should the default implementation look like? Quite frequently in an actor-based system, the default implementation of this particular problem of passing data around is usually just to pass it up to the caller. At a certain point, the calling actor or launching actor knows what to do with that data and wants to pass it to specific entities, but quite often the default thing that you want to do is just pass it up the chain, right? Well, how do you do that? In interfaces, you don't have class data, as I mentioned before, so I can't pack a queue reference into the interface because it doesn't have any class data, right? So if you try and unbundle, you get a broken wire there. So how do you send it? Well, we could do something like this, where we try and typecast this to an actor, and then now that we have the actor class wire, we can get the queue reference and send it that way. This actually doesn't work though, because this method is a protected scope method, and this interface is not part of the actor framework. It doesn't descend from actor, so we can't actually call this method. This doesn't work, and it also just feels really dirty. It feels kind of gross casting this to an actor this way. There's something about it that kind of seems a little bit off to me. So when thinking about this problem, I kind of was trying to kind of think of a way to solve this, and I realized that this iCatch data interface is always going to be an actor. Any class that implements this is going to be an actor. First of all, this is tied directly to the actor framework because it has a message class, and that message class inherits from the actor framework message class. So you've already got a direct kind of coupling to the actor framework. You've got a actor structured interface with a library and a message. So even though this iCatch data interface isn't technically coupled to the actor framework, I know in real use, any implementer of it is going to be an actor, so I can enforce that. Well, how do I do that? Well, I created another interface called I'm an actor. And this interface has two methods, get caller and queuer and get self and queuer. Those are kind of the core methods that an actor would use to get references to its queue, get references to its caller. And interfaces can inherit from other interfaces. So my root actor or my iCatch data actor or interface inherits from this I'm an actor interface. So now any implementer of the iCatch data interface must also implement this I'm an actor interface, which has these two methods, get caller and queuer. So what does this now look like? So now we have a default implementation that is iCatch data. The default thing is we know that this is an actor, so we get the actor queue, and we call the same message and just pass it up the chain. So now we have a default implementation that all of our actors in the hierarchy can implement without having to bloat those modules with tons of message routing code. Similarly, I have an I can log interface, and my I can catch data is in I am an actor. In my applications, all of my actors are loggable actors. I use a lot of event logging. I'm a big proponent of event logging. I've given some presentations on it over the years. We have a publicly available event logging repo, Compose Systems, Bitbucket, event logger. You can find that online. But we've got a default implementation that's also got some event logging built in, the same kind of methodology. So that's kind of how one of the main ways I use it with the actor framework. So another use case is from refactoring some legacy code. So one of my main projects that I work on is a customer who has an application that I'm trying to think is probably maybe 15 years old in terms of one person started it, another person worked on it more, another person, I think, seen some head shakes. Some folks know about this type of code where, many people over the years have had their hands on it. and it's grown, and everyone has their own kind of programming style. And so everyone, when they get their hands on it, they say, hey, the last person sucked, so I'm going to do it my way. And so there's 10 different ways that this application is written, but it's a fairly large application. It's about 7,500 VIs. I know it's a relative term. Some people think that's huge, and some people think that's smaller. I would say it's medium to large for what I do. But the kind of core design of this application is what I have here, where there's this deep inheritance hierarchy where all of the classes in the project inherit from, there's a base logging class, then there's a base UI update class, then there's a base root device class, and then you have all your kind of concrete devices, like, I've got a whiz-bang, a turbo atom smasher, and a digital output device. These are the abstractions around hardware, but they're already several layers deep in an inheritance hierarchy. And each of these objects is put into a type-defined cluster. I've got, just for the simplicity of the display, I've got 3 classes here, but the real cluster has about 25 classes in it. And each one of these classes is fairly large. They're complicated classes, so they've got a good amount of code in them. And this turbo cluster, as I call it, is kind of passed around all throughout the application. So most of the methods in the application have a dependency on this big cluster, and that kind of causes, if you've ever worked with a large application with lots of coupling, you know what it kind of can do to the LabVIEW IDE. So this is what this looks like. So you have your turbo cluster, and then if you want to call turbo smash, you just unbundle it from the cluster and call it. This is kind of what most of the code in that application looks like. So the problem with this is that the IDE is really, really slow. So this is an ongoing project for me where the customer will say, hey, we have a new feature we want to add. Can you add this? Or we're going to switch this piece of hardware for this one. Can you add a new driver for this? There was a time where they requested a kind of a fairly large refactoring of how a core part of this application worked. And it was a big chunk of work for me to do. And like I said, many people have had their hands in this code. The person who wrote it wrote a lot of the core elements of this, wrote it in a way that's different than I would write it. So I wrote it the way I wanted. And it wasn't really easy to bring that into the application in a small way. So I wrote this big new chunk of code, bring it into the application. And once I did that, the build times were already in the range of an hour and a half, 2 hours. But I hit a point where about 75% of the times builds just weren't working. It would run for an hour, 2 hours, and sometimes it would say that it produced an EXE. I don't know if anyone else has ever seen this, and the EXE would be like 4 kilobytes, and it says it all worked. But basically, my experience has been, I don't know what other people have seen, is that LabVIEW can build really large applications, and LabVIEW can build applications where you have a lot of heavy coupling between modules. But there seems to be a threshold where if you have a lot of heavy coupling and you have a lot of code, there's a certain threshold where the compiler just is like, I can't do this anymore. And I hit that point. And I think a core reason for this was because of this kind of dependency of this big cluster. Problem was that to remove this cluster's dependency from everything would have taken months at the minimum, and it would involve a lot of risk, right? Touching lots of pieces of code everywhere. So the ideal short-term solution was to refactor the cluster to remove some heavy dependencies. So first I want to emphasize that you can kind of refactor this type of design with regular LabVIEW classes. You don't need interface to do this. What you can do, so as I mentioned, there's this deep inheritance hierarchy where you have this concrete module that inherits from all these other modules, and you want to get rid of the deep inheritance hierarchy and have something much cleaner where you have an abstract turbo controller and then your concrete turbo controller below it. So the way to do this with regular classes, this is called the adapter pattern. You create a new abstraction, and then your concrete implementation of that abstraction just calls the old code, right? So you still have your old code. You haven't changed anything in terms of the concreteness of what's being called. You've just created a new layer of abstraction around this. The problem with this is that this is kind of tedious to do, to go through and manually write these VIs for all of these classes to refactor this would be a whole lot of work. And not only that, but for each class that you are doing this with, you're adding 2 new classes, right? You're adding a new abstraction and you're adding the concrete implementation that calls the legacy concrete implementation. So you're adding a lot of extra new code. And it's also kind of potentially error prone that, what if you forget to bundle the class back into your wrapper? What if you don't properly map all your inputs and outputs down to the thing? So there's a good chance that you're going to make a lot of mistakes and you're adding a lot of new code. So again, interfaces to the rescue. I kind of, after messing with this for a little bit, I've realized that it's pretty easy to script an interface. So I wrote this little bit of code that I can give it a class. I have a little simple UI that I use that shows all the public methods of the class. And I say, write an interface that defines these methods. So you have all the VI paths from your class, you have your template class path, and you just create a new interface that has all these methods, duplicate the connector pane, and then now set that class to be a child of the interface. So now this is what this looks like. I've created a Turbo Atom Smasher interface. I removed the concrete dependency from this turbo cluster on the Turbo Atom Smasher driver. And I've only created one new class, and that class is very thin. It's an interface that doesn't have any concreteness versus if I was using regular LabVIEW classes to solve this, I would have had to create 2 new classes. So what was the end result? It didn't really change the build times very much. It kind of seems to fluctuate around 2.5 hours. But it did create a pretty massive improvement in the IDE's responsiveness, how quickly the project loads, how much time I had to wait for things to spin when I would make a change to class data. But the biggest thing was that there was a real concrete improvement in the build success. It's really, really frustrating to be working with the customer on something where they're wanting new builds or fixes for things, and you kind of have to shrug your shoulders and say, well, what do you want? It's not working. And I don't know how to fix it. Not a good look. Doesn't make me happy with LabVIEW. So when I have a build that's not working, it's a pretty big deal to me. And this improvement in build success is a huge win for me. So another use case is for shared resources. So we have modules from different hierarchies that all kind of call the same resource in the same way. So a very straightforward example of this is event logging. I mentioned earlier that pretty much all of the actors in any application that I write are going to call an event logging module. I want to know when an actor starts. I want to know when an actor stops. I want to know if an actor gets an error. So all of my actors are capable of logging events, even though they may be part of totally separate inheritance hierarchies. And the way that I'm calling that shared resource, the event logging module, is the same pretty much across all these different actors. So even though they have a different inheritance hierarchy, the behavioral access to this resource is more or less the same. So this is what the concrete code would look like prior to using interfaces. And an interface implementation of how to clean this up is create an iLoggable interface or an I-can-log interface. NI actually recommends to not use the I naming convention from other programming languages that a lot of other programming languages use for interfaces. Me personally, I like using it. When I look at things on disk files, I like to be able to see that something's an interface through the I notation. And not only that, but it also goes back to what I was talking about earlier about code that makes sense to me. Like this idea of naming this I can log, that instantly tells me this is a module that can log, right? It makes sense to me. It's not confusing. And it also maps to that idea of code modules being these behavioral entities. Again, makes sense to me. I think makes code that makes more sense and is easier to read. So I use the convention of iLoggable. So what does this look like? I mentioned earlier that interfaces do not have private class data. So how does this iLoggable store the log event reference? Well, it doesn't. That's the dynamic dispatch code, right? The actual concrete implementation is in the actors is unbundling the log reference, and then the static code that's actual log event is the same across all of them, right? All we really want to do is call this log event method. The dynamic dispatch part is taking it out of class data. So this is what an iLoggable class looks like. One big improvement here is that you now have one single log event method in your project instead of having a log event for all your different drivers. So every time you bring up quick drop, you've got 10 different log events and you got to go select through one. Now you have one log event and you can put it on any wire. This is just another kind of little trick that I use when I'm launching actors or even initializing modules. A way for transferring resources between them is to use a little bit of malleability. I pass an object in, and if it's a loggable, I give it the log reference, and if it's not, I just pass the object out. This is malleable, so the type on the wire at edit time doesn't change. It's another, again, useful interface use case. Just checking my time here. So another use case is callback interfaces. With actors, you're sending a module a message, and it's kind of an asynchronous thing that's running off on its own, right? There's something called the Hollywood principle. Don't call us, we'll call you. The idea here is when you tell something to do something, rather than checking on it every 100 milliseconds, say, hey, do this thing and tell me when you're done, right? So asynchronous request and reply. I'm going to ask you to do something and I want you to tell me when you're done. And I think most of us have seen some sort of API where you have something like this, right? Where you tell something to do something and there's a event reference that you can pass in and it will generate a user event or something of that sort to tell you that this thing that's happening in the background is done. The problem with that is that you're kind of coupling your requester to the reply type, right? If you're passing in a user event, you've now made the assumption that the caller of this API is going to be using user events. So I like to use an abstraction, a callback abstraction, so that the consumer of my API can use whatever type of callback they want. If you're using the actor framework, you can use an actor implementation of the callback. If you're using user events, you can use a user event. If you're using queues, you can inject a queue. So that's the idea of this interface-based callback implementation. So what does this actually look like? So I have a valve control actor that has a method, setValve. It's running independently. Usually in a concrete system where you set a valve, you probably don't want to do anything else until the valve has actually been set. I tend to want to know whether or not that actually worked correctly. So I send the message to the valve controller, but I also want to know when it was complete. So what's happening here is I have a message class that implements the callback interface. And this message, so where we see inject request callback, I'm passing a message here, and that message implements the callback implementation. So when the valve controller is done with setting the valve, it just sends this message back to this actor. And the kind of the advantage here over using a standard class, using an interface rather than a class, is that you don't have to create a separate implementation of this the callback class. You can use something that you already have here. So like the example I'm giving it is in the actor framework. I already have a message to send to this actor something. I can use that message that already exists. If you're using a different module where you have some type of object defined for sending messages to your module, whatever, if that's a DQMH module, whatever, you can make it implement this interface and then you just pass that directly in and it calls that. So what does this kind of look like? So this is the valve controller. We send it a message, say this is the valve name, this is the state, whether we want it to open or close, and then the request callback is what gets passed here. So this whole thing happens here. We have a contract that defines what's the interlock for that particular valve. Check the interlock. If the interlock works, we set the valve. Check to see if there's a post condition. Is there some position sensors or something like that should be in a specific state after the valve is set. If so, check that. And all this happens. Again, we see we've got the loggable, and once it's done, we send the operation status back to the caller. And this valve controller doesn't know anything about the caller. It just knows that there's this abstract request callback. If there's no implementation, if you don't care, that it doesn't do anything. So yeah, again, what does this look like? We've got this request callback method or interface, and the callback message. I have created a generic iCatch request callback interface that I frequently use. And then the easiest way to implement this with my actors is to then just override catch request callback. I will pass, come back here, a string into the message to tell it the request type. When I get this request back and call the catch request callback, you've got information about what the request was sent with the request status. So some closing thoughts. I think I've probably got a little bit of time for questions. One of the key things to kind of remember between the distinction between an abstract class and an interface is that an abstract class defines an is-a relationship, whereas a interface defines a can-do relationship. One thing to note is that they are just another tool in the toolbox. I find them very useful. I don't know if other people have this same thing where when you pick up a new tool, I know for me, collections was a big one where when collections were introduced into LabVIEW, I was kind of immediately like, oh, these are awesome. And then I found myself just using them everywhere, including in many situations where I was like, why am I not using an array here? An array is actually the correct solution, but I was so in love with collections, sets, and maps that I was using for everything. Interfaces, kind of the same thing. If you're not using them, you can kind of pick them up and start to think, oh, these are awesome. They're just a tool and toolbox. They're not going to fix all your code problems, but they are useful. And so if you haven't played with them at all, I would highly recommend starting to play with them a little bit. Just even just taking one class in your application thing. Is there a way that I could kind of use an interface here, play with it a little bit? And I find that when I start doing things like that, playing around with designs, it's my brain kind of just finds other places like, oh, this would be a good spot for an interface. So if you're not using them, I hope this presentation has made a case to use them. They are just another tool in your toolbox. Again, I want to mention that object-oriented in general and interfaces, if you're using them and you don't feel like they're making your code cleaner and easier to read, something's probably gone off the rails, right? If you feel like it's just making things really complicated, that's not the idea. The idea here is not to make your code complicated. The idea is to make your code cleaner, easier to read, more simple. And then finally, go to GDevCon. It's awesome. All right, I've got some time for questions. Anybody has any?
Back to your first one of doing the message routing. Mm-hmm. By doing that default implementation, you kind of are able to get rid of half the messages, I think, all the things that are going up to the root, right?
Yep.
But you still have to have specific instances for it to go back down the chain to the more specific one. Is that, am I understanding that right? So you used to have, you now have half as many implementations as you did before.
Yeah, so passing up the chain is more generic and passing down is more specific, right? And that kind of, at least to me, makes sense where going upwards, the low-level concrete details don't necessarily know as much about the system as the higher-level launching actors, right? So if I have, just to get kind of concrete, if I have a hardware manager actor that manages the lifetime of all my pieces of hardware in my system, that hardware manager actor has a contextual knowledge of all the pieces of hardware in the system. So when it receives a message from one actor, and maybe that message needs to go back down to another actor, it knows, it has the contextual knowledge of this is another actor in the system, whereas the instrument actor doesn't know anything about the other actors, right? So I think that makes sense, and yes, it's a correct way to think about it, that it's generic up, specific down. Does that kind of answer the question? So yeah, it reduces a lot of the messages going up, but you still are going to have some degree of concreteness going down.
Including word.
Yeah.
I have a follow-up to that question. Like, I'm a little lost as to how the interface is removing the dependency from the nested actor up to the root actor when you're messaging back. Like, because now isn't your dependency just on the interface, which they both now depend on? So it's like there's still dependency interjection on?
So the data acquisition model does depend on the interface now. It does not depend on the root model, though, or the root actor. It just depends on this interface. Does that answer the question?
Yeah, but then your root actor is going to depend on that interface as well, right?
Yes, the root actor is an implementer of the interface.
So it's like they're not directly coupled, but they're still kind of coupled through a third party, if you will.
They're coupled through the interface, right? They both depend on the interface, which is kind of what you want, right? And again, this is a very simple example, but as your code grows, having that root actor be dependent, and especially if you have multiple layers, having each one of those be dependent on concreteness, that's kind of where you run into problems like the build problems I was talking about. This interface that it depends on is super thin, right? It's a one method or one interface and then a concrete class that doesn't really do anything versus being dependent on a class with 30 methods, which also may depend on some other things. Does that make sense?
Yeah, I think so. Thanks.
So yeah, it's not like you're totally removing all dependencies. It's you're kind of slimming down the dependencies is a way to think about it.
I guess I did have a question about your build times, and did you ever try enabling debug to help get past that unsuccessfulness?
I've enabled debug. I've done the debug logging. I spent a lot of time kind of banging my head against the wall. I've played a little bit with, going back to the AI thing, trying to have AI look at some of the build files and see if it's helped. My former coworker, John McBee, said that he had Google Gemini look at some output files, and it found something in one of his classes that reduced his build times from like an hour and a half to 20 minutes. I haven't found that level of success yet, but I spent a lot of time messing with a lot of every little option I could. I spent trying to figure out what that problem was.
Builder roulette didn't work for you.
It didn't. It was one of those things where if you have a build that works only 25% of the time, and I toggle it and it works, and then I toggle it off again and it also works, or I toggle it on and it works and then it doesn't work. It's like, is that real? Like, it's because, and the problem is when you have something that takes 2.5 hours, you can't run 100 different scenarios to kind of concretely figure out what is the thing, because there's so many different variables. And usually when this happens to me, it seems like it's like a customer's breathing down my neck about wanting to get something out, and it's like, I got to figure this out. So, yeah.
Good, thank you.
So I don't want to change the topic into build issues because this isn't a question, it's a statement. But in my build issues, there's an INI key that will keep the build VIs instead of deleting them when the build is done. Mm-hmm. And so a lot of times I would do a build and it would say, it broke during the build process. And it's like, well, that's weird. So this INI key keeps the files on disk. So then when the build fails, you can open that on disk and see what is broken. And then that usually led me down to this actor or this library or class had some malformed weirdness that I could then investigate. It doesn't fix all problems. Like you said, when a build claims it's successful and the exe is tiny, that's not going to have that solution for that. That's completely different. But at least for me, when it would be like it broke during the process, which was my most common, I could look at the interim VI files that it made to try and figure out what went wrong.
Cool. Do you know what the key is? I think maybe if I just Google
it's
something
not on
similar.
the top of my head, I'm sorry, but I
can
found
find
it on
it.
a wiki page of some kind, so
Okay.
I'll see if I can dig it up.
Cool. I'm always interested in build times and issues around building because that's kind of a perpetual problem, especially when you're working on large applications like this. Running into problems there and trying to debug them is, at least for me, has been a huge time sink. So any tips there, I'm always happy to hear.
Sorry, another question. On the, you called it a callback interface. Mm-hmm. I got a little bit lost there. Are you sending an interface message then back with the message to the caller? And then, so yeah, so that last slide that you just had. So right there, that inject request callback message that you have down there at the bottom. So that purple wire, that's an interface then that you're feeding in?
So yeah, the purple wire is a message class. However, the input to that method is an interface. So if you were to open up the front panel of that, you would see iStatus request callback. But because that message class implements that, you can pass it in.
Okay.
Does that make sense?
So you're passing the specific one in.
Yep.
But then on the flip side, then when you are messaging it back, do you have that slide where you're messaging it back? So this one right here.
The method variable at the bottom. So this is the request callback interface. That's the interface wire. And then if you were to dig into the implementation of that for the message, it's just sending itself. So if I go back to here, what's happening is I'm injecting the queue to send. So that message class has a method that's send to myself.
Gotcha. So then your caller doesn't have to know anything about how to specifically implement that.
Correct.
The
Exactly.
interface is just keeping it general.
Yep, exactly. And I find this pattern of using this abstract callback really useful because while I tend to use actors for everything in the end application, often I'll write a driver and I want to test it with just a simple one loop event-based test panel. And so I can create a event-based callback where I have my test panel, I press a button, and then I get a user event that's generated when the callback is executed. So keeping that generic rather than a concrete type has been pretty useful for me. And I think it also can hopefully make using my APIs easier for other people because you're not tied to any particular framework type.
Okay. Sweet. Thank you.
Cool. Well, thank you, everybody. And thank you to the folks at NI. And again, one more plug for GDevCon. Thanks for those folks. And hopefully I'll see some of you there. Thanks.